a blank terminal, and a blinking cursor. This is the MSF6 prompt, the entry point to the most capable penetration testing platform in the world. Before 2003, testing network security meant juggling dozens of disjointed, incompatible scripts. The Metasploit framework brought those separate tools into a single, highly structured armory. To understand how it works, look at these two components. An exploit targets a software flaw to create an entry point. The payload is the functional code executing specific instructions once that entry point is established. Supporting this strike are auxiliary modules, which scan the perimeter and gather reconnaissance before you attack, and encoders, which wrap your payload in obfuscated code to hide it from antivirus software. This modular architecture creates a standardized industrial-scale methodology for identifying and testing vulnerabilities. Operating this framework requires absolute fluency in its specific command line vocabulary. Locate exactly what you need from thousands of modules using the search command. Once found, arm your specific weapon by typing the use command. No operator fires blindly. Running info and show options reveals the exact parameters and requirements the exploit needs to function against the target. Next comes the targeting phase. You use the set command to lock in the target's IP address, known as rhosts, and your own attacking machine's IP, called lhost. Finally, typing the run command is the irreversible trigger. Once pressed, the assembled components launch across the network. Knowing what these commands do is easy. Stringing them together flawlessly under pressure is what separates a novice from a professional operator. The exploit only gets you inside the perimeter. What happens next depends entirely on your payload selection. Complex payloads won't fit inside an initial exploit. Attackers use staged payloads. A tiny stager slips through the vulnerability, establishing a connection to pull the heavier stage through. To bypass defenses, we use a reverse payload, where the compromised machine reaches out to the attacker. The ultimate stage payload you want to pull through that reverse connection is a tool called Meterpreter. A simple payload might give you a single command execution. A staged Meterpreter payload gives you total, persistent control over the system. Meterpreter's primary defensive advantage is its form. It runs entirely in memory, leaving 0 physical files for standard antivirus software to detect. Once resident, it can automatically elevate its own administrative privileges using the getSystem command, or migrate itself into a normal background process, like Windows Explorer, to hide in plain sight. From that hidden position, it gathers deep intelligence. It can silently log every keystroke or instantly capture live screenshots of the user's desktop. When a Meterpreter session successfully opens, the physical owner of that machine is no longer the one in control of it. Let's see this sequence applied to a live target using EternalBlue, the same vulnerability that enabled the massive WannaCry ransomware attacks in 2017. We start by typing search EternalBlue to find the exact module, then use the use command to lock it into our active prompt. We set the rhosts variable to our Windows 7 target, set the lhost to our attacking machine, and attach a reverse TCP Meterpreter payload to bypass any local firewalls on the way back out. We type run. The framework fires the exploit, slipping the stager through the vulnerability, and we wait for the encrypted connection to return. The prompt returns a Meterpreter session. We type sysinfo to verify architecture, getSystem to lock in administrator privileges, and hashdump to extract the passwords for offline cracking. In 6 calculated commands, a theoretical software flaw becomes total system compromise. The adrenaline of the initial breach is only a fraction of the job. Real penetration testing requires meticulous management of the intelligence you extract. Metasploit contains a built-in database. As you scan or compromise targets, it automatically logs every discovered host, port, and vulnerability. No manual entry. Managing multiple operations? Simply switch workspaces, keeping sensitive intelligence from different client engagements entirely isolated. Maintaining organized intelligence is the barrier separating a chaotic amateur from a methodical professional. Make no mistake, possessing these sophisticated offensive network capabilities immediately brings you under intense, unforgiving, and severe legal scrutiny. There is an absolute non-negotiable requirement for explicit written authorization before targeting any system. Testing without permission is never a gray area. Deploying these modules outside of contracted engagements or your own personal lab is a criminal offense, carrying severe financial penalties and lengthy prison sentences in almost every jurisdiction. The ethical operator uses this platform for one reason: to identify weaknesses and prove they exist, so the network can be fortified against actual threats. The digital armory is now open to you. How you choose to wield that power and the consequences of those choices rest entirely on your shoulders.